beginning the recording as of now. The time is 6:04 p.m. This is the regularly scheduled meeting of ITSE 2309 on July 17th, 2018. Still have a cough today. Our topic for today comes from Module 10, and it is data conversion. And we talked about data types last time. Today, we're going to talk about converting from one data type to... Hello. Byman, you said? I'll just assume you just had your mic on. That's okay. The server supports two types, implicit and explicit. And I'm going to point you back to your programming class. You had a programming class in some language or another. And let's say it was C or Java. And in C or Java, for example, if you were to, let me just, new window here. If you were to talk about, I have an int I gets, I don't know, 5. And I know it's giving me, because I'm writing in C, but I'm in the SQL window. And if I have a character variable, char ch, and I want to assign it to I can do this. So ch is a character. Ch is character data. But I want to give it this integer value of 5. And the question is, what will happen here? What will happen if I assign an integer to a character? Now, I know I'm talking in C here, and some of you haven't taken the C programming language. And what will happen is that the ch will get the character with of 5. And I'm not sure what that is. If I said it was 2, let's make it 2 just for funsies. If I said it was 2, that would be a happy face. That would be the single character happy face. Is kind of like an emoji or something. And 1 is also a negative happy face. It's a happy face where it's like a negative of the slide. But anyway, there's lots of things we can do like this. So if we do this, this is called data coercion. And so what it does is that it, since I'm putting the integer value into a character value, it does something. And so it just gives it the character with ASCII code 2. And it works similarly the other way around. If I gets ch, for example, ch gets the character uppercase A, and then I gets ch. Well, I will get the ASCII code of ch, which happens to be, and if I were truly writing in C, I would need to put them in double quotes. No, it would be in single quotes, wouldn't it? because it's a single character, single quote. So if I said I get CH, I would get the ASCII code of the character A, which would be 65. So I would get the value 65. And you can look up these ASCII values of what would happen. Similar things happen when you convert floating point to integer, integer to floating point. Converting integer to floating point really isn't a problem because it just picks up a 0. Converting floating point to integer can be a problem because it just chops off the decimal places. Okay, enough of that. In SQL Server, there are implicit and explicit conversions. So we were seeing conversions that happened in other programming languages, and sometimes these are called coercions and promotions. If it goes from a larger one to a smaller one, it's called a coercion. For example, if I force a floating point into an integer, I have to chop it off. On the other hand, if I give an integer into a floating point, I make it larger. That's called a promotion. SQL Server, sometimes SQL Server we have implicit and explicit data conversions. So implicit, let's look at that first. Implicit means that the database engine will convert the data type automatically and the user doesn't see it. Explicit means that you have to say how it should be converted. Okay? For example, let's say I have two variables, and for right now, these are just variables. These are fields in a table. We don't officially know about variables in our database yet, in our database language yet. We will very shortly, or we will at the very first part of the next class. But for right now, val1 and val2 are fields of a table, and that's what we know as variables. So this would come for select val1 plus val2 from some table as total. Now, what would we see? Well, one of them is a 2 and one of them is a 3. So what do we expect to see? Any thoughts?
Well, an implicit conversion.
Implicit conversion is probably what we will see, and I think we will. So 2 plus 3. And so we'd probably see the value 5. Total would probably be printed as 5. So it would probably print, the total is 5. Yeah, and that makes sense. So if it's a character value, maybe it's character 1, maybe char 1 is the integer 2 plus 3. So it converts this character string to an integer and then adds it. Okay. Now on the other hand, let's say that value 1 were the character string hello, and value 2 were the character string 3. Now the question is, what would I see if I said select value 1 plus value 2? What would I see? It probably would be hello 3. Okay? It will always attempt to convert everything to the string that has the highest precedence. And this is why sometimes strange things happen, because it cannot convert hello to an integer. So it does the best it can. It converts the integer to a string. Therefore, you get the string hello 3. Because plus, when you put it between strings, means concatenate. So it concatenates value 1 to value 2. I'm not entirely sure that I would not see the string 2, 3 here. That could happen. I expect to see the value 5, but it is possible that I would see the character 2 concatenated with the character 3 and displayed as a string, and I would see 2, 3. That is possible. So basically using implicit conversion is a little bit dangerous because I'm not entirely sure what I would see. In the second example, I would definitely see the string hello 3. When you mix data types, SQL Server will try to do something with it. It will try to convert everything to the one that has the highest order of precedence. And sometimes you will get errors when you try to use this. And sometimes things will happen that are kind of strange, like you get this hello 3 business. I'm going to move to the next slide now. The cast. Okay.
One question.
You said what?
One question. Do we know?
Turn your volume up a little bit if you can, or put your mic a little closer.
Any better?
Yeah, that's just a minute.
Okay.
Wendy?
Yeah.
Okay.
Yeah,
my wife just got home. Okay. Go ahead.
Precedence. Do we know what is that order of the precedence?
Yes, I'm coming to that here in a minute.
Okay.
Yeah. It essentially it's just a chart that tells you that. All computer languages let you change from one data type to another. It does not change the object, but it changes the way it looks, and then as it goes through it, it comes out and it changes. So if I cast something in the expression, the object changes from one to the other, but the object itself doesn't change. Languages vary in the rigidity in which data types are enforced. C is very loose. Java is very, very strict. And SQL tends to take a middle ground on it. So SQL is sometimes strict and sometimes loose. An SQL Server, and here I've used the name of the language, Transact SQL or T-SQL, TSQL is frequently used, is the language that is underlying this. And this is actually the topic of the next course. The cast function converts an expression from one data type to another data type, and it works thus. Expression is cast, some expression, as data type, and if there is a length on it, it has to do with it. For example, here are some examples. Cast 14.85 as int. What would you expect? I'm going to cast 14.85, and that is going to chop it down to an integer. So you're going to get 14. Okay. Cast 14.85 as float, and the result is not truncated. Cast the integer 5 as float, you will end up with 5.0. This is what is known as a promotion. Cast 15.6 as varchar. You will get the string of 4 characters, the 1, followed by the character 5, followed by the character decimal, followed by the character 6. This is a character string. This is not a number. It's a character string. Not sure why I put this one in. Cast as varchar 4. Don't know. And finally, cast 12 2014-5-2 as date time. The result will be the date. Now, I know this is, I put this in quotes. I'm not sure whether this really should be in quotes or not, but once I said cast, this is a string. This is a string. And this is the way it should be done when you put a date into a date. So when I insert something into a date time, I really should insert this value, cast 2014-5-2 as date time. This is the way to do it. Now, if I just inserted this directly, that would be an implicit conversion. But once I cast it, that is an explicit conversion. Explicit is always better because that's... SQL Server provides a fairly rich set of cast operations. Convert is slightly different from the cast function, and the idea about convert, I'm going to talk about convert a little bit in a minute, or do I talk about it now? Let me see. Okay. Convert does some cast. If I try to say cast hello as date time, you're going to get an error. Now, I don't have any real formatting options, but if I say convert invoice date, convert varchar invoice date, so convert to a varchar invoice date. So convert is different from cast. I generally use cast, but convert is not found in other SQL products, but it is unique to SQL. Now, if you look up in the book about convert, differences between convert and cast, convert is mainly used for changing dates to characters and applying a specific format. So let's, since Google is our friend, convert, and I'm going to search on 107. I don't remember exactly what that is. The convert function, convert 7 or 107. So 107, if you convert with the format string either 7 or 107, it's going to give you the month written out. So for example, today would be JUL 17, comma 2018. So let's try it. Select convert. Get date 107. So I'm telling it to get the date today, get today's date, and apply format 107. I am expecting to see July, JUL 17, 2018. Let's find out if we see that. And it doesn't like that. Let's see, I guess I'm not supposed to put those on it, am I?
If you take out that comma.
No, I don't think so. Let's see. How do I get the date? SQL.
Capitalized.
Well, it shouldn't make any difference. I think it's just get date. Convert get date. As, guess I got to give it a, okay. Oh, I have to convert it to something. There. Okay, and there's my result is JUL space 2018. So what am I saying? I'm saying convert to a varchar today's date and apply 107 to it. If all I did was apply 7, for example, I would see just July 17th, 18. So I would see it without the 19 on it. Let's see, what else do I have on there? Got quite a few other options. For example, if I want to see it in the 07, 17 YYY, I apply. So I want to see the day first, followed by a dot, followed by the month, followed by the year. I would apply format number 104 to it. Let's see that one. Let's apply format 104. And we'll execute that. And I see it with the date first, 17.07.2018, and that's supposed to be a German format. But I can see it in any format I want, so convert is one of those things that gives that to us. It's commonly used for dates. Questions on that? Cast is the computer science method of doing that. Convert is usually done to a varchar or a char field, usually varchar, and it's usually used for converting dates or numbers to a character format. And there's times when you want it to do that. Okay, so dates are fine. I can print out a date, but it gives us, converts it to character, and it applies a format to it. Now, the one that I like better than that, really, is what we call the try convert. Now, try convert is unique to SQL Server. However, I expect to see it pushing its way out into the other databases very shortly. And try convert is really nice. It has a similar functionality in most languages. So I'm going to cast, what is this? Oh, that's May 32nd. Well, what day of the week is May 32nd? There isn't a May 32nd. That is an invalid date. Or, for example, if I were to talk about February 29th on a non-leap year, it would be an invalid date. So I'm going to try to cast this guy, 2016, the 32nd of May, as date time. Now this is the default string, and there is no such date. Therefore, we're going to get an error message. We can't do this. Let's prove it. And if I go back over here, let's undo. And so if I try to do this thing, I'm going to get, for my reading pleasure, can't do it. It's wrong. It's just, but on the other hand, if I use the try cast and I say try cast this as date time. Now, sometimes you don't want to get an error message because errors, when an error happens in your script bombs out and it stops executing. And we don't like errors that happen in our scripts. So let me put this one in here, and I'm going to try to cast this as a date time. It will fail. However, notice what I get. Instead of getting an error message, all I get is a null. So it can't do it. So it just gives me a null instead of giving me an error that just stops the world. Does that make sense? I'm pausing now for questions.
No, it makes sense.
Ah. Well, I'm glad to hear that. Sometimes you don't want, sometimes, most of the time I will use cast, because if I try to cast this, good grief, I know it's not going to work, okay? So if I try to cast something like May 29th or May 31st, everything's going to be fine. But if I try to cast 32nd, I'm going to have an error. But if I do a try cast, so if I have some value, for example, in a string, I ask, the person from a web page, enter your birthday. So they enter something like this. And I don't know what they're going to enter. And so if I just try to cast it, I'm going to barf. But if I use try cast, then I'm just going to get a null value. And if I insert that into their record, that's fine. I'm just going to get a null value in the record because there is no such date. And sometimes that's preferable to having everything error out and just stop the world. Makes sense.
I'm sorry. Mistakes in data entry. You can catch the mistakes in data entry.
Right. More. Let's see. I don't catch the mistake. I just kind of ignore the mistake, put in a null, and go on. There's ways of catching the mistake, but that's that's a matter for later. Returns null if the conversion cannot be done. I expect to see a try cast come up in the next SQL standard. It's just, I think it's just time for it to happen. Let's see what's coming up next. Try convert. Oh, where's my content? Guess I need to write the content for the page of try convert. Try convert works like try cast, tries to convert it to something, and it tries to put it usually converts it to varchar, usually, most of the time, and it tries to put a formatting on it for you, like 107 or 103 or something like that. But if it can't do it, it just returns null. Like try cast, it works about the same way. And golly gosh darn. Let's look at the assignment. Let's see. This is the quiz. Quiz is pretty easy, as they are supposed to be, actually. Okay, this particular module, I think, is a 20-pointer, I believe. Now, this one is really as easy as it seems to be. You can get this one done in a hurry. Write a select statement that returns 4 columns. So it could just be one single select statement, one select select invoice total. So the first one we're going to do, we're going to cast invoice total as, so the cast to return the first column as data type decimal with 2 digits to the right of the decimal. So what is decimal with 2 digits? That's decimal comma 2. So I have to give it enough for everything and then put a comma 2. So let's see. Invoice total based on the invoices. Let's do the first one. So select cast invoice total as decimal. I would give it probably 10. 8 should be enough. We'll try it. And 2 to the right of the decimal.
So 8 will be the total length, including the decimal.
Yes, 8 is the total length. Now I might overrun that on some of them. I don't know about invoice total. I might push that up a little bit more, and let's go up to 12. Doesn't hurt anything to go a little bit larger. So let's see. The reason it's giving me the finger there is I have not selected my database.
So does it include the decimal in the count?
It will include the decimal because the decimal will have 12 total, and 2 to the right of the decimal. So cast invoice total, and I might
9 digits.
No, there will be a total of 12 digits altogether. And 2 of it will be a maximum of 12 digits altogether, and 2 of these will always be to the right of the decimal place. So I will have 10 digits to the left of the decimal place, if I have that many, and 2 to the right. Always 2 to the right, whether I have 2 or not. If I don't have 2, there'll be 2 zeros. Now, this is going to turn into an integer, as I pointed out. So if I were to execute this, I'm going to see everything with 2 decimal points on it. And this is one way to do currency. Although currency actually is a very large value, and it has 4 digits on it, because 4 digits to the right of the decimal, because the default on money is always by international standard 4 decimal places. Therefore, we had to create a coin that was 1/100th of a penny. Believe it or not, every country has a unit of money. Our unit of money in the United States is the dollar. In Japan, it is the yen. In Mexico, it is the peso. And you can go on and on and on. but every one of those is divided into, every one of those has a decimal point and 4 digits to the right of the decimal point by default. Even though in general practice we don't use anything except 2 digits, the 4 digits are still there, believe it or not. So if I say decimal 12 comma 2, that means that I have 10 digits to the left of the decimal point, a possibility of 10 digits to the left. If I don't use 10 digits to the left, fine. I will always have 2 digits to the right. If there are more than 2 digits to the right, then they just get chopped off.
And how about left if the number is smaller?
Say again?
Instead of 12, if we put 2.2, oh no, 4.2.
4 comma 2. I'm not sure exactly what's going to happen here. I guess we can find out. I think I'll probably see an error, and I will get an error there because I have had an overflow. I'm too big to go into that. So if I say something that's too small, then I'm going to get an overflow. I can say, I can just say simply no decimal place. In that case, when I do it, I just don't get a decimal. So it just chops it off. I can say 4 to the left of to the right of the decimal. I don't know whether I'm going to get anything or not on that. They're all, looks like they're all zeros to me, but it would be quite possible. Let's see, did I see one that wasn't? Would be quite possible to have something that is not 0 in those last 2 ones. For example, if I put in 1/3 or something, 1 divided by 3, where I got a non-terminating decimal, then I would end up with 0.3333, and then it would terminate, because we will terminate when we get to the 10,000th place. And that's just, we figure if you get something smaller than that, it's not important. It does turn out to be important because if we are in a loop or something and I were losing one, let's see, what would that be? Tenths, hundredths, 10,000ths. I were losing some 100,000ths of a dollar. It could amount up to a significant amount of money over a period of time, which is the issue with. Anyway, so here's one of them. This is what so this is the first one. Looks like this, cast. So if you go to this guy, it says, write the select returns 4 columns. That's one of them. That's this one. I did the first one for you. Use it to return the first column as type decimal. Use the cast to return the second column as type varchar. Cast it to varchar. Try convert, and then put style 1 on it. Number 2 is it's just write 2 select statements, so it is pretty easy. So we're using the cast function, and we're using cast, try convert. This one should seriously take you about 10 minutes to do. If it takes, it should take you about 5 minutes, but I'm going to allow you 10 minutes. Are there questions?
Not at this time.
Are there questions on anything? I am working on module 7. For those of you that I haven't, I was just about done with it. I had like 1 or 2 more left, and then I got called out today just as I was getting finished with grading module 7. So there's like 2 people I haven't gotten to yet. I promise I'm going to do it right as soon as I hang up here tonight. I'm going to go finish grading Module 7. So if your Module 7 has not been graded, Mr. Nelson and I don't know, someone else. Bottom line is, if you've turned it in and you see it turned in Canvas, it's turned in. Maybe I haven't gotten to it yet. I've had I've had a rough week, and I'm not going to give you lots of excuses, but I'm a little bit behind in my grading. I'm going to turn on the test 2 practice test, and I would like to spend some time in a lab going over the practice test instead of just giving you the assignment. So I'd like to go over it with you and have a lecture on it where we actually do it hand in hand. I'll still give you your 5 points for doing it. I'll tell you what, I'll give you your 5 points if you participate in the class or do it. Oh, well, whatever. So I'm going to turn on the practice test 2, even though we're a little ways away. When is it? When is that coming up? Okay, let's see. We got data types we're pretty much done with. Okay, we've got module 11, which is functions, and then we have, so I'm going to go ahead and, let's see, unpublish the test. I'm going to unpublish the solutions right away. There's the discussion. And when shall I make this due? When am I going to do test 2? It's time to think about that. Let's see, we're going to do functions on the 19th. Let's set test 2 then tentatively for July 26th. So I'm going to make the practice test due then on July 26th. And I want it to be, so they'll come available on July 26th. So I'm going to make it due at noon on July 26th, and then at noon on July 26th, the test will become available. Practice test doesn't carry a whole lot of weight, but I do want to have time to go over it with you, so I'm going to take some time to do that. And now you can go look at it now. You can read over it. You have plenty of time on it.
The practice test is due on July 26th.
Practice test is due at noon on July 26th, and the test 2 will become available at 12:01 on July 26th. And I expect it to go through the weekend. So that will be a Thursday.
Okay, now when will you discuss the practice test?
July 24th, I expect.
Okay, before we turn it in?
Yeah, before it's due.
Okay.
And so if you want to go back and rework it, I mean, the way I work on the practice test, if you do it, you get full credit. I don't go in and argue with you on an answer. If you do it, you're going to get your bennies when you come to the test.
Yeah, and I was thinking that if we due that time, at least we want to do it. So after we do it, then we can discuss. That's it. So that
Yeah,
means
you
we
should
have
do
to
it
get it
before
done.
the 24th, and then we'll go discuss it. And then if there's any issues in it, then you'll have, if you've already turned it in, fine, turn it in again. I'm not going to grade it before I grade the test anyway.
Okay.
So basically what I'm going to do is I look at those and I ask, did you do it? So I will put the solutions out there on the 24th, and we will discuss it on the 24th. How's that?
Okay.
Okay.
Now, assignment 8, the second problem that one cast.
Well, let me get there.
I haven't completely read that chapter yet.
Assignment 8 or module 8? That are they the same
Assignment
thing?
8. Assignment 8. The one you did one problem.
Subqueries or this last one? Chapter 8?
Yeah.
Okay. What about it?
No, you went over one problem, one assignment of first problem.
Yeah, I'm trying to show you how easy it is. It's easy.
Okay. I had a question on the second problem. I looked at.
I'm not going to do it for you, but you can go ahead.
Okay. All right then. I'll try.
Well, it just says you're just casting it, instead of casting it to a decimal, 12.2 or whatever. The 12 is just big enough. You're casting it to a
number of bits.
Yeah, you cast it to a varchar. You just cast it to a varchar. That's all.
Second problem, number 2. Problem number 2.
Problem number 2. Float.
Yeah. 53 bits precision.
Oh, that's you just cast it as a look. Look that up. Basically, it's a you cast it as float.
Okay.
Float 53.
Oh. Okay.
Okay. This is an example, and then this number 2. So the second one is an example of it, 53-bit precision. So cast as float 53. So if you want 64-bit precision, you say float 64.
Okay.
Returns 4 columns based on a number. Cast it as varchar. Try convert varchar style 1, and then as float. Give each column a meaningful name. So each column has to get a name. Notice that in this one right here, notice it has no column name. Yeah. I should not see that. I should see some name. I don't care if you name it X.
Okay.
Well, it says a meaningful name. Is X meaningful? I would probably say it was if it was meaningful to you. Just give it a name.
Okay.
As.
Okay.
Questions?
Yes. Now, I did not quite understand 2's complement. Is that necessary for us to understand that?
Oh, gee, let's see. I talked about that in the, okay. 2's complement is important to programming. It's not particularly important to understanding database. 2's complement is the reason why my example of what state is farthest east, what state of the United States is farthest east, and it turns out to be Alaska because it extends into the eastern hemisphere, so it's a trick question. And so what happens is if I have let's say I have a digital, excuse me, an old analog speedometer on my bicycle, for example. I have an old speedometer that it's not a digital device. So if I pedal backwards, it runs backwards. So if I start out at 0 and I start pedaling forwards, the first number I come to is 1, and then 2, and then 3, and then so on. If I start pedaling backwards, let's say that the highest I have on my speedometer is a 10. I probably have 1,000 miles on it, but let's just say I have 10. So I pedal forwards, I get a 1 and a 2 and a 3 and a 4 and so on. If I pedal backwards, I get a 9 and an 8 and a 7 and a 6 and a 5. Now, if I were to put that into digital, then I would get for example, if I had the highest number I could have where it would be an 8, let's say 8 miles was as big as I could go on this hypothetical speedometer, and I start pedaling forward, and the first one is 1 or 0, 0, 1, and then 0, 1, 0, and 0, 1, 1. If I pedal backwards, the first number I would come to would be a binary 7, which would be a 1, 1, 1. And then I go backwards another mile, and I would have 1, 1, 0. And another mile, and I would have 1, 0, 1 or 5. And then another mile, and I would have 1, 0, 0. And now I have bumped into my positive numbers. So my positive numbers are coming up and my negative numbers are going down. And this is the thing of 2's complement. Now, if I look at the bit on the far right side, if that bit is a 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, or 1, 1, 1, if that bit is a 1, then I have a negative number. If it is a 0, either 0, 0 or 0, 1 or 1, 0 or 0, 1, 1, I have a non-negative number. Notice I didn't say positive because 0 is in there. And that is the essence of 2's complement. So in 2's complement, I have exactly one way to write 0. There is no such thing as positive 0 and negative 0 is the whole idea. It gets me away from that. Okay, that's the long answer. The short answer is I don't intend to ask you anything about 2's complement.
Okay. Okay, I'll figure it out in due time as long as your time.
It works that way in every programming language. It's a very important idea in computer science. You're going to run into that if you ever take a class in assembly language.
Okay.
Not so much in database because it's not real important to database. We just go out and throw more memory at it. If we have a problem with an overflow, in other words, if our integers overflow, but this is why when an integer overflows, a signed integer, it has positive, negative. When it gets as big as it can get and you add one more to it, then it becomes negative. And this is because of the way 2's complement behaves.
Okay.
Okay. Well, it's almost 7 o'clock.
Okay.
Okay.
So we'll see you on Thursday, right?
I'm sorry?
Again on Thursday?
Today is Tuesday. Yes, we're going to meet on Thursday, and we're going to do the next module 11.
Okay. All right then. Thank you. Good night.
Okay, I'm going to end the recording now. Stop.